Let's begin with a question that changes everything once you understand it. Why is the universe so empty? Not empty in the sense that nothing exists. Plenty exists. Stars, galaxies, nebulae, planets, moons, asteroids, comets, dust, gas, radiation. The universe is full of stuff, but it is empty in the way that matters most. It is empty of connection. Look at any image of the cosmos, and you'll notice the same thing. Vast, incomprehensible stretches of nothing, between every object, space between planets, space between stars, space between galaxies, space between galaxy clusters. The universe is not a crowded room. The universe is a desert with occasional grains of sand, separated by distances that would take lifetimes to cross. Brian Cox has spent his career studying the laws that govern this emptiness. He is a particle physicist at the University of Manchester, a professor who has dedicated his life to understanding the fundamental rules that shape reality. And after decades of study, he has arrived at a conclusion that most people find deeply uncomfortable. The universe isn't accidentally lonely. The loneliness is built in. It is engineered into the foundations of physics itself. Every fundamental constant, every law of physics, every feature of the cosmos seems to conspire toward the same outcome. Isolation, separation, loneliness on a scale that makes human loneliness seem trivial. The universe creates life and then makes absolutely certain that life can never find each other. This is not a coincidence. This is architecture. And once you see it, you cannot unsee it. Let me show you what I mean. Let me walk you through the laws of physics one by one and show you how every single one of them points in the same direction, toward a universe that is magnificent, awe-inspiring, beautiful beyond description, and absolutely, fundamentally, irreversibly alone. Start with the most famous number in physics, the speed of light, 300,000 kilometers per second. It sounds fast because it is fast. Light can circle the Earth 7.5 times in a single second. It can reach the moon in about 1.3 seconds. It can reach the sun in about 8 minutes. By any human standard, light is extraordinarily fast. But here is what Brian Cox has explained with characteristic clarity throughout his career. The speed of light is not fast enough, not even close. It is fast enough for our solar system. It is fast enough for the local neighborhood, but it is catastrophically, absurdly, laughably too slow for a universe this size. Light takes 4 years to reach the nearest star, 4 years traveling at 300,000 kilometers per second, and you've barely left home. Light takes 100,000 years to cross our galaxy. 100,000 years. Every civilization that has ever existed on Earth, every empire, every language, every war, every love story, every human being who has ever lived, all of that fits inside a window of about 10,000 years. Light needs 10 times that just to cross the Milky Way, and the Milky Way is one galaxy. Cox has pointed out something about the speed of light that most people miss. It is not just a speed limit. It is not just the fastest anything can travel. It is the fastest that information can travel, the fastest that cause can propagate to effect, the fastest that anything can influence anything else. The speed of light is the speed of relevance, and at cosmic scales, relevance travels so slowly that by the time it arrives, everything has changed. Think about what that means. If a civilization on the far side of the galaxy sent us a message right now, traveling at the maximum speed the universe allows, that message would arrive in 100,000 years. The people who sent it would be long dead. Their civilization might not exist anymore. The message would be a ghost, an echo from a world that vanished millennia before the signal reached us. And that is just within our own galaxy. The nearest large galaxy, Andromeda, is 2.5 million light-years away. A message sent today would arrive in 2.5 million years. 2.5 million years ago, our ancestors were just learning to use stone tools. The entire history of the genus Homo fits inside the travel time of a single light beam crossing the gap between neighboring galaxies. The universe made the speed of light precisely fast enough to tease us and precisely slow enough to isolate us. But the speed of light is only the first piece of architecture. The second is gravity. Gravity is the force that builds everything. Stars, planets, galaxies, galaxy clusters. Every large structure in the universe exists because gravity pulled matter together. But gravity has a peculiar property that Brian Cox has discussed in detail. It is absurdly weak. Of the four fundamental forces of nature, gravity is by far the weakest. It is about 10 to the 36th times weaker than electromagnetism. That is a 1 followed by 36 zeros. You can demonstrate this weakness trivially. Pick up a paper clip with a small magnet. That tiny magnet is overpowering the gravitational pull of the entire Earth. The entire planet, all 6 trillion kilograms of it, is losing a tug of war with a piece of metal you can hold between 2 fingers. Why does this matter for loneliness? Because gravity's weakness is what determines the size of the universe's structures. If gravity were stronger, stars would be smaller and closer together. Galaxies would be denser. The distances between everything would shrink. Life, if it emerged, would have neighbors within reach. But gravity is weak, fantastically, incomprehensibly weak. And because it is weak, it needs enormous amounts of matter to become significant. Stars must be massive. The distances between them must be vast. Galaxies must sprawl across tens of thousands of light years just to hold themselves together. Cox has reflected on this. The weakness of gravity is not a flaw in the universe's design. It is a feature that simultaneously allows complex chemistry, stable stars that burn for billions of years, planets with solid surfaces and distances between those stars, so vast that no civilization could ever bridge them. Gravity gives us life and takes away company in the same breath. Let me put concrete numbers on this. The average distance between stars in our region of the galaxy is about 5 light years. That means our nearest neighbor, Proxima Centauri, is roughly 40 trillion kilometers away. If you could drive a car at highway speed without stopping, it would take about 50 million years to get there. The fastest spacecraft humanity has ever built, the Parker Solar Probe, would need about 6,300 years. This isn't because the universe is trying to be difficult. It is because gravity is weak. And weak gravity means stars need enormous amounts of matter to ignite. Enormous amounts of matter spread across a galaxy means vast spaces between each concentration. If gravity were 10 times stronger, stars would be roughly 10 times closer together. The nearest star might be half a light year away instead of 4. That would reduce the travel time dramatically. But Cox has noted the cruel trade-off. Stronger gravity would mean smaller, hotter stars that burn through their hydrogen in millions of years instead of billions. There wouldn't be enough time for complex life to evolve on any planet. You'd have a connected universe with no one in it to enjoy the connection. The third piece of architecture is thermodynamics, specifically the second law. Brian Cox has spoken about this law more than almost any other physicist alive. He built an entire BBC series around it. He has called it the most important law in all of physics. And when you understand it fully, you understand why the universe is not just lonely now, but will become lonelier with every passing moment until it is the loneliest place imaginable. The second law of thermodynamics says that entropy, the disorder of a closed system, always increases. Things fall apart, structures decay, order dissolves into chaos, sandcastles crumble, stars burn out, civilizations collapse. This is not pessimism. This is physics. The arrow of time points in one direction only, and that direction is toward greater disorder, greater uniformity, greater emptiness. Cox has described the implications with devastating poetry. Life, he has said, is a temporary structure on the long road from order to disorder. Stars are temporary. Planets are temporary. Galaxies are temporary. Everything complex, everything interesting, everything capable of thought or feeling or wonder, all of it is temporary. The universe began in a state of low entropy, high order, concentrated energy. It will end in a state of maximum entropy, total disorder, energy spread so thin and uniform that nothing can ever happen again. The timeline of this dissolution is staggering. Our sun will exhaust its hydrogen fuel in about 5 billion years. It will swell into a red giant engulfing Mercury and Venus and scorching the Earth beyond habitability, before shedding its outer layers and collapsing into a white dwarf. That white dwarf will cool over trillions of years, fading from white to yellow to red to brown to black. Eventually, it will be a cold cinder floating in empty space, radiating nothing, contributing nothing, doing nothing. Doing nothing, every star in the universe will follow this path. Some faster, some slower, but all of them will die. In about 100 trillion years, the last stars will burn out. After that, the universe will contain only stellar corpses, white dwarfs cooling to black, neutron stars spinning down to silence, black holes slowly evaporating through Hawking radiation over timescales so long they make the current age of the universe seem like the blink of an eye. The final black holes won't evaporate for something like 10 to the power of 100 years. That is a 1 followed by 100 zeros. A number so large it has no meaningful comparison to anything in human experience. Nothing happens, Cox has said, and it keeps not happening forever. That is the heat death of the universe. That is the final state toward which everything is heading. And in that final state, loneliness is not even the right word. Loneliness implies someone who could feel lonely. In the heat death, there is no one left to feel anything. There is no one and nothing and nowhere. Just uniform, eternal emptiness. But thermodynamics enforces loneliness long before the heat death. It enforces loneliness right now, because the second law means that every complex system, every civilization, every living thing, exists only briefly. Civilizations rise and fall, species evolve and go extinct, stars ignite and burn out. The universe creates islands of complexity and then dissolves them. It creates minds capable of wondering whether they're alone and then ensures that those minds exist for only an instant in cosmic time. Brian Cox has described civilizations as flickering candles of meaning in the cosmic darkness. They appear, they shine for a moment, and they go out. The window during which any civilization exists is vanishingly small compared to the age of the universe. And for two civilizations to find each other, they would need to exist at the same time in the same region of space, both looking for company. The odds are astronomical against it. The second law guarantees that this temporal window stays narrow. No civilization can last forever because the second law won't allow it. Complexity requires energy gradients, differences between hot and cold, between ordered and disordered. As entropy increases, those gradients diminish. The fuel runs out, the structures decay, the candle gutters and dies. Now consider the fourth piece of architecture, quantum mechanics. This might seem like an unlikely contributor to cosmic loneliness, but Cox has explained how it fits into the picture with particular insight. Quantum mechanics governs the very small, the atoms and particles from which everything is built, and it introduces a fundamental randomness into the fabric of reality. At the quantum level, events are probabilistic, not deterministic. Particles don't have definite positions until they're measured. Radioactive atoms decay at random times. The behavior of individual particles is fundamentally unpredictable. This randomness is not a gap in our knowledge. It is a feature of reality itself. Einstein famously objected to this, saying that God does not play dice. But the evidence is overwhelming. Reality is, at its deepest level, random. What does this mean for loneliness? It means that the emergence of complex life anywhere in the universe is not inevitable. It is not guaranteed. It is the result of an extraordinarily improbable chain of quantum and chemical events, each one contingent on the last, each one subject to randomness. Life on Earth required a specific sequence of mutations, environmental conditions, and cosmic circumstances stretching back billions of years. Change any one of those quantum dice rolls and we might not exist. Cox has spoken about the rarity of complex life, with particular emphasis. It took the best part of 4 billion years. He has noted, to go from the origin of life on Earth to a civilization. That is a third of the age of the universe. This suggests that the steps from simple chemistry to intelligent life are extraordinarily difficult. Each step requires the right quantum dice roll. Each roll is independent. The probability compounds into something vanishingly small. If intelligent life is rare, genuinely rare, cosmically rare, then the universe's architecture of loneliness makes a kind of terrible sense. The speed of light doesn't need to be fast enough to connect civilizations. If there are barely any civilizations to connect, gravity doesn't need to push stars closer together if the chemistry of life almost never produces minds. Thermodynamics doesn't need to allow longer, lasting civilizations if civilizations almost never arise in the first place. The architecture is redundant. Every law points the same way. Every constant reinforces the same conclusion. Even if life were common, the speed of light would isolate it. Even if the speed of light were faster, thermodynamics would ensure civilizations are brief. Even if civilizations were long-lived, quantum randomness would ensure they're vanishingly rare. The universe has built not one wall between its inhabitants, but many walls stacked behind each other. Each one sufficient by itself, all of them together forming a barrier that nothing in physics can overcome. Brian Cox has reflected on this redundancy. He finds it one of the most striking features of the cosmos. In engineering, you build redundant safety systems when failure is unacceptable. The universe appears to have built redundant isolation systems, as if ensuring that life never connects with other life is a priority woven into the fabric of reality itself. Now let me introduce the fifth piece of architecture. The expansion of space. We've discussed the speed of light as a limit on how fast information can travel. But the expansion of space is something more sinister. It is not just that the universe is large. The universe is getting larger every second, and the rate of expansion is accelerating. In 1998, two teams of astronomers discovered that the expansion of the universe is speeding up. Something, a mysterious force now called dark energy, is pushing space apart faster and faster. This discovery earned the Nobel Prize in 2011, and its implications for cosmic loneliness are devastating. Because of dark energy, the observable universe is shrinking, not in absolute terms, but in practical terms. Galaxies that are currently visible are being pushed beyond the cosmic event horizon, the boundary past which light can never reach us. Every year, roughly 160 billion stars cross that boundary and are lost forever. Not destroyed, lost, carried away by the expansion of space to distances from which no signal, no spacecraft, no information of any kind can ever return. Cox has discussed dark energy as perhaps the most profound contributor to cosmic isolation. The speed of light makes travel slow. Thermodynamics makes civilizations brief. Quantum mechanics makes life rare. But dark energy actively erases the universe. It takes galaxies that were once reachable and makes them unreachable. It takes stars that were once visible and makes them invisible. It is not a static barrier. It is a dynamic one, growing stronger with every passing moment. In the far future, trillions of years from now, the night sky will be empty. Every galaxy beyond the local group will have been carried beyond the cosmic event horizon. A civilization arising in that era would look up and see nothing. No distant galaxies, no cosmic microwave background, no evidence that the universe was ever anything other than a single lonely galaxy floating in an infinite void. The expansion would have erased the evidence of its own history. Think about what this means in concrete terms. Right now, the observable universe contains roughly 2 trillion galaxies. 2 trillion, each one containing hundreds of billions of stars. The James Webb Space Telescope can photograph thousands of them in a single exposure. Future civilizations will see none of this. They will have no idea that 2 trillion galaxies ever existed. The expansion will have hidden the evidence so thoroughly that no amount of technology could recover it. The universe will have lied to them through omission, presenting itself as a small, simple, lonely place. Cox finds this one of the most haunting implications of modern cosmology. We happen to live during a brief window in cosmic history when the universe still shows its hand. We can still see the evidence of the Big Bang in the cosmic microwave background. We can still see distant galaxies receding. We can still measure the expansion and deduce dark energy. We can still understand the architecture, but this window is closing. The evidence is disappearing, and once it is gone forever. This is not speculation. This is physics. The equations are clear. The measurements are precise. Dark energy is real. The expansion is accelerating, and the universe is systematically removing itself from our reach. The loneliness we experience today is the least loneliness any future civilization will ever feel. Tomorrow will be lonelier. Next century lonelier still. The architecture doesn't just enforce isolation, it deepens it over time. Let me bring all 5 pieces together. The speed of light makes travel between stars take centuries or millennia. Gravity's weakness ensures stars are separated by light years of empty space. Thermodynamics guarantees that civilizations are brief candles in cosmic time. Quantum mechanics makes the emergence of intelligent life staggeringly improbable, and the expansion of space actively erases the universe, pushing galaxies beyond reach and darkening the sky year by year. 5 laws, 5 constants, 5 features of reality, all independent, all pointing in the same direction, all enforcing the same conclusion. The universe is designed for loneliness, not designed by anyone. Cox is careful about that. He doesn't mean designed by a creator or an intelligence. He means designed in the way that an arch is designed by gravity or a snowflake is designed by chemistry. The structure emerges naturally from the rules, and the rules, all of them, produce isolation. Brian Cox has spoken about what he calls the unreasonable effectiveness of isolation. It is a play on the physicist Eugene Wigner's famous phrase about the unreasonable effectiveness of mathematics. Wigner marveled that mathematics, a human invention, should describe the physical world so precisely. Cox marvels that the physical laws, which have nothing to do with loneliness or isolation, should produce loneliness and isolation so thoroughly. Could the universe have been different? Could the constants have taken values that allowed connection instead of isolation? In principle, yes. If the speed of light were 1,000,000 times faster, interstellar travel would take days instead of centuries. If gravity were stronger, stars would be closer together. If the cosmological constant were 0, the expansion wouldn't be accelerating. If the constants were different, the architecture of loneliness might not exist. But Cox has pointed out the devastating catch. If you change the constants to allow connection, you often destroy the conditions for life. Make gravity stronger and stars burn through their fuel too quickly. There isn't time for complex life to evolve. Make the speed of light faster and the electromagnetic force changes. Chemistry works differently. The bonds that hold molecules together, the very bonds that make biology possible, would be altered beyond recognition. The constants of our universe appear to be fine, tuned for life. This is well established in physics. The range of values that allow complex chemistry, stable stars, and solid planets is extraordinarily narrow. We exist in a universe whose constants permit life. But those same constants, the very same values that make life possible, also make isolation inevitable. Life and loneliness appear to be package deal. You cannot have one without the other. Consider the strong nuclear force, the force that holds atomic nuclei together. If it were just 5% weaker, deuterium would be unstable. Without stable deuterium, the chain of nuclear reactions inside stars that produces carbon, oxygen, and all the heavier elements necessary for life would break down. No carbon means no organic chemistry. No organic chemistry means no life. But the strong nuclear force at its current value also determines the size of atoms, which determines the density of matter, which determines the size of planets and stars, which contributes to the vast distances between them. Or consider the electromagnetic force. It is the force responsible for chemistry, for the bonds between atoms that make molecules possible. If it were slightly different, water wouldn't have its unique properties. Ice wouldn't float. Liquid water, the solvent in which life's chemistry occurs, might not exist in stable form, but the electromagnetic force also determines the speed of light, which determines the universal speed limit that isolates every island of life from every other. Every force, every constant, every fundamental parameter of the universe serves double duty. It enables life and enforces isolation simultaneously. There is no adjustment you can make that preserves one without destroying the other. This is perhaps the most profound insight in all of cosmology. The universe is not hostile to life. It allows life, but it allows life only under conditions that guarantee that life will be isolated. The fine-tuning that produces consciousness also produces cosmic solitude. The very laws that allow you to exist are the same laws that ensure you will never meet anyone from another world. Brian Cox has spent considerable time thinking about what this means philosophically. On his Joe Rogan appearance, he put it starkly. "We are responsible," he said, "for destroying meaning in the galaxy if we fail. If civilizations are rare, if this architecture of loneliness is real, then each civilization that arises is precious beyond measure. Not because the universe values it. The universe values nothing, but because there is so little of it. Meaning is rare because life is rare, and life is rare because the architecture demands it. There is a strange paradox here. The architecture of loneliness, the very thing that isolates us, is also what makes us extraordinary. In a universe teeming with civilizations, no single civilization would matter much. But in a universe where the laws of physics conspire to make life rare and connections impossible, every civilization matters enormously. Every conscious mind is a defiance of the architecture. Every moment of awareness is a rebellion against the loneliness built into the cosmos. Cox has described this beautifully. "We are the cosmos made conscious," he has said. "Life is the means by which the universe understands itself. In a lonely universe, this understanding is precious precisely because it is so improbable and so temporary. The universe created the conditions for minds to arise and simultaneously created the conditions that ensure those minds will be alone. And somehow, in the teeth of that loneliness, those minds look up at the stars and feel wonder." Let me address the objections. People always raise objections when confronted with this conclusion. The most common is that we don't know everything. Physics might be wrong. New discoveries might change the picture. Wormholes might exist. Warp drives might be possible. Some undiscovered law might allow faster than light travel or communication. Cox is sympathetic to this hope. He understands it. He shares the desire for a less lonely cosmos, but he is a physicist, and physics is about what is, not what we wish. The speed of light as a limit is not a tentative hypothesis. It is woven into the structure of space-time itself. Einstein demonstrated this in 1905, and every experiment since has confirmed it. Overturning it would not be like discovering a new particle or force. It would be like discovering that 2 plus 2 doesn't equal 4. It would require not just new physics, but physics that contradicts everything we've observed for over a century. The mathematics is unforgiving. As any object with mass accelerates toward the speed of light, its effective mass increases. At 90% of light speed, the mass has roughly doubled. At 99%, it has increased by a factor of 7. At 99.9%, by a factor of 22. And as the object approaches light speed, the mass approaches infinity. Infinite mass requires infinite energy to accelerate. Infinity is not a budget anyone can afford. It is an absolute wall, unyielding and permanent. Wormholes, if they exist at all, would require exotic matter with negative energy density. No such matter has ever been observed. The energy requirements would be beyond anything conceivable. And even if a wormhole could be opened, it might be unstable, collapsing before anything could pass through. Stephen Hawking proposed the chronology protection conjecture, the idea that the laws of physics conspire to prevent anything that would violate causality. Cox agrees this is likely correct. The architecture protects itself. The second objection is that alien civilizations might be so advanced that they've found ways around the laws of physics, technology we can't imagine, solutions we can't conceive. But Cox has addressed this clearly and repeatedly. Technology works within the laws of nature. It does not override them. We cannot build a perpetual motion machine no matter how advanced our technology becomes. We cannot decrease entropy in a closed system. We cannot accelerate mass to the speed of light. These are not engineering challenges. They are absolute limits. An alien civilization 1 billion years more advanced than us would have unimaginable technology. They might control stars, manipulate matter at the atomic level, harness energies we can barely conceive. But they would still be bound by the speed of light. They would still experience entropy. They would still exist for a finite time in a universe that grows emptier with each passing moment. The architecture of loneliness applies to them exactly as it applies to us. The third objection is perhaps the most interesting. Some people argue that the universe isn't designed for anything. It just is. The constants are what they are. The laws are what they are. There is no design, no intention, no architecture. Things just happen to work out this way. Cox would largely agree with this. He doesn't claim the universe was intentionally designed for loneliness. He is not making a theological argument. He is making a structural one. Whether the constants were set by chance, by necessity, by a multiverse of possibilities, or by something else entirely, the result is the same. The laws we live under produce isolation. The architecture exists regardless of whether anyone planned it. And this brings us to the question that Cox returns to again and again. The question that matters most. If the universe is designed for loneliness, what do we do about it? The answer, Cox has suggested, is that we accept it, not with despair, not with resignation, but with clarity. The loneliness is real. No one is coming. No alien civilization will visit us, save us, guide us, or confirm that we matter. The architecture forbids it. The laws enforce it. We are on our own. Cox has spoken about this with particular force in his documentary Human Universe. There is nobody out there to value us, he has said. Nobody out there to look after us. This is not a complaint. It is a call to action. If the universe has built an architecture of loneliness, then the responsibility for meaning, for purpose, for survival, falls entirely on us. We are the only ones who can give our corner of the cosmos significance. And if we destroy ourselves, if we squander this improbable gift of consciousness through short-sightedness or conflict, the loss is not just ours. It may be the loss of the only meaning that has ever existed in this entire region of the galaxy. Cox has noted, with some frustration, that while we should be pouring resources into understanding our situation and securing our future, We spend more on trivial pursuits than on the fundamental science that might extend our survival. The architecture of loneliness has given us a narrow window, a brief flicker in cosmic time when consciousness exists and understands itself. Wasting that window is not just foolish. It is, in a cosmic sense, tragic. But being on our own is not the same as being nothing. Being on our own means that everything we build ourselves. Every problem we solve ourselves. Every moment of beauty we create ourselves. The loneliness of the cosmos is not a verdict on our worth. It is a description of our situation, and our situation, while lonely, is also extraordinary. Consider what we are. We are arrangements of atoms that have learned to contemplate the cosmos. We are matter that thinks. We are stardust that wonders. We arose on a small rocky planet orbiting an ordinary star in an ordinary galaxy, and in the brief flicker of our existence, we have decoded the laws that govern the universe. We have looked at the architecture of loneliness and understood it. We have measured the speed of light. We have calculated the strength of gravity. We have discovered entropy and dark energy and quantum mechanics. We have read the blueprint of our own isolation. We built the Large Hadron Collider, a ring 27 kilometers in circumference beneath the Swiss-French border, to smash particles together and understand the forces that shape reality. We launched the James Webb Space Telescope 1,000,000 miles from Earth to capture light from the first galaxies. We sent Voyager 1 beyond the solar system with a golden record containing the sounds of our world, a message thrown into the void by creatures who know the void will never answer. These are not the actions of a species defeated by loneliness. These are the actions of a species that understands its loneliness and reaches outward anyway. That is not nothing. That might be the most remarkable thing that has ever happened in the cosmos. Brian Cox has said that the fact we can perceive the beauty of the universe with visceral wonder is a thought worth celebrating. The architecture gave us loneliness, but it also gave us the capacity to understand the loneliness. And understanding is its own form of connection, not with other civilizations, but with reality itself. There is a poem in the physics. The same equations that isolate us also describe the dance of electrons around atoms, the fusion reactions that power stars, the quantum fluctuations that seeded galaxies. The architecture of loneliness is also the architecture of everything beautiful. The speed of light determines the color of a sunset. Gravity shapes the spiral of a galaxy. Entropy drives the seasons, the tides, the aging of wine, the growth of a child. Quantum mechanics gives us the periodic table, the chemistry of DNA, the neurons that allow you to understand these words. The loneliness and the beauty are the same thing. They come from the same source. They are built from the same constants. You cannot separate them. A universe that allowed connection between civilizations might not produce sunsets or DNA or conscious minds. The price of beauty is solitude. The cost of consciousness is isolation. And somehow, despite that cost, here we are, conscious, aware, wondering. Cox has expressed this with an eloquence that comes from decades of wrestling with the implications. We are rare, he has said. We are precious. Not because the universe has declared us so. The universe declares nothing, but because the architecture that governs reality makes life an almost impossible achievement. Every mind that arises, every civilization that flowers, every moment of consciousness that flickers into existence is a statistical miracle, a rebellion against the overwhelming probability of emptiness. And here is the final thought, the one that Cox returns to in his most reflective moments. The architecture of loneliness is not a punishment. It is not a cruelty inflicted on life by an indifferent cosmos. It is the necessary condition for life to exist at all. Change the architecture and you lose the life. Keep the life and you keep the loneliness. They are inseparable. Two sides of a single cosmic coin. This means that every time you look up at the stars and feel small, feel alone, feel that ache of cosmic isolation that humans have felt since we first raised our eyes to the night sky, You are feeling the price of your own existence. The loneliness is the receipt for the miracle of consciousness. It is the trade the universe made: complexity for isolation, minds for solitude, wonder for emptiness. And the trade, Cox would argue, is worth it. The loneliness is real, but so is the wonder. The isolation is permanent, but so is the beauty. The silence of the cosmos is absolute, but within that silence, on one small planet orbiting one ordinary star, something extraordinary is happening. Matter is thinking about itself. The universe is understanding its own architecture. And that understanding, that brief, flickering, improbable understanding, is worth all the loneliness in the cosmos. Brian Cox has dedicated his life to this understanding. He has stood on mountaintops and pointed at the stars. He has sat in lecture halls and drawn equations on whiteboards. He has spoken to millions through television screens and podcast microphones, and the message always is the same. The universe is magnificent. The universe is lonely, and those two facts are not in tension. They are the same fact seen from different angles. The universe is designed for loneliness. Every constant, every law, every feature of reality points that way. The speed of light isolates us. Gravity separates us. Entropy dissolves us. Quantum mechanics makes us rare. Dark energy erases the evidence that anything else ever existed. The architecture is thorough. The isolation is complete. But within that architecture, something happened that the loneliness cannot touch. Minds arose. Consciousness flickered into being. Creatures made of atoms looked up at the sky and asked why. The architecture couldn't prevent that. The loneliness couldn't stop that. The laws that isolate us are the same laws that created us, and creation, even lonely creation, is still creation. Look at the stars tonight. They're beautiful and unreachable. They're magnificent and indifferent. They're evidence of an architecture that will never allow you to visit them or know who might live among them. But they're also evidence that the same architecture created you. The same physics that enforces your isolation also sparked your consciousness. The same constants that guarantee your loneliness also permit your wonder. That is the universe Brian Cox has spent his life studying. Not a cruel universe, not a kind universe, a lonely one. And in its loneliness somehow, beautiful beyond anything the architecture should have allowed. We are alone. The physics is clear. The constants are measured. The architecture is understood. No one is coming. No one can come. The walls between us and everyone else in the cosmos, if anyone else exists at all, are built from the most fundamental features of reality itself. Those walls will never come down. But look at the person next to you. Look at the world around you. Look at the sky above you. All of it exists because the architecture allows it. All of it is beautiful because the constants permit it. All of it is precious because the loneliness demands it. In a universe teeming with civilizations, nothing would be special. In a universe designed for loneliness, everything is. Cox knows this. Physics knows this. And now you know it too. The universe is designed for loneliness, and that is exactly what makes it so unbearably, heartbreakingly beautiful. The isolation is the point. The solitude is the source. The loneliness is where the wonder lives. That is the architecture. That is the design. That is home.